it's an idea about bringing machine learning models as tables, and why we're doing this, and how we did this for MySQL and Postgres, and a demo. That's essentially what we're going to walk you through. The first thing is anyone that has dealt with machine learning before understands that clean data is a fundamental ingredient to it. And a lot of clean data already exists in databases. Like actually when you put information in a database and in tables, you're kind of like turning that into information per se. So the main requirement for machine learning is already existing in like many databases out there. And therefore, if it already exists in databases, it makes sense that we could try to bring machine learning to the database itself. And can we do this? Can we perhaps train models and use models straight from the database? And maybe machine learning or applied machine learning actually better lives in the application layer, in the data layer rather than the application layer. So let's assume that we can. And perhaps if you think of a machine learning model, you can think of a machine learning model as a table where you can select the variables that you want to predict, and you pass the conditions for your prediction, and that's essentially what you have. If you can do this, we would like to call this particular kind of tables a little bit different than how you can call a normal table. Let's call them AI tables. And the main difference between an AI table and a regular table is that when you query an AI table, you're actually getting information that is generated upon being queried. Whereas when you query a real table, you're getting actual data that exists in the database. But functionally, they should behave the same way. And if we start doing this thing, then again, we can start moving the machine learning components from the application layer to the data layer. And in our opinion, this structure of machine learning lives better in the data layer because that's the main source of any machine learning model is information. And even when you consult the machine learning model, once it's being trained, you're actually just querying a model. So by making this transition, perhaps we need to also think of, well, if we can query machine learning models as tables, can we train them? Can we test them as we actually use a database as well? And one way to do this, and is of course what people do today, which is using PyTorch, TensorFlow, and all this. And many people love it. But in reality, most developers and most people that are using databases, they understand machine learning, but they would like to get their hands into solving the problem rather than building the machine learning part. So we should cater for both, rather than just allowing people to test and create models separately and then loading them into a database. It's thought that maybe machine learning automation, it's also a great fit for databases themselves. So think of the process of creating a table. It's very similar to the one of creating a model. You want to, define whatever columns you want to predict, and perhaps you want to do it from what data you're going to load it from. And if you think about this, probably the best interface will be, well, I would like to create a new AI table that will predict these columns from this given table, and use all the other columns from that table as input, and publish that as whatever I want to publish it. So we thought that maybe we create a construct, which is a table called predictors, in which you can insert that very same statement. You want to insert what is the name of the columns that you want to predict, from what table you want to learn, and also how do you want to publish this. Then that will be an instruction for an AutoML framework to actually go and take that task and build and train a model and test it and do all the things that AutoML is good at, and then publish that as a table that you can query as if it was a real table. So with this idea in mind, we thought, well, still what we want to ensure is that people that are in the application layer, they can consume these tables in the best possible way and in a seamless way as well. So if people within the application layer, they don't see any differences from the AI tables and the normal tables to just connect to a database, we can perhaps use this very nice feature of many databases of today, which is federated storage. And in that way, we can publish specific tables that don't exist in the database. But when you connect to your actual database, be it MySQL or Postgres, you still see these tables as if they existed there. And the same way, you can pull the information that you need to generate and train from the table itself. So the way that we do this, again, Postgres has foreign data wrappers. MySQL has the federated store engine. MariaDB has a connect engine. So by using this, we can kind of essentially embed these AI tables into the databases that actually support query storage. And in that way, we can bring machine learning and AutoML down into the data layer. I think that the best thing from now is to show you an actual demo, because this is something that is already built, and we actually are announcing right now in Percona. So I'll hand it over to Soren, and he will guide you through the actual experience.
Thank you, Jorge. So let me just share my screen. Okay, so hello everyone. So my name is Zoran Bandowski, and I'm working as a full stack developer in MindsDB. In this 10 to 15 minutes demo, I will guide you and present to you how you can train and query the machine learning models directly from PostgreSQL database by using MindsDB AI tables features. As a prerequisite for this one, you will only need to have MindsDB installed, which could be installed as any other Python module. So you will do pip install MindsDB, and that's all. And after that, you're starting just with Python and MindsDB. After MindsDB started, it will create some of the prerequisites for connecting to your databases and provide you an option to to integrate with those databases. So right now, what we will try to do in this demonstration, it's let's imagine that we had airline passenger satisfaction data inside our PostgreSQL database. What this table contains is an airline passenger satisfaction survey data. Let me just quickly show you how the data looks in our PostgreSQL. So I will try to select from the table. This table contains different features as class of the travel class in the plane of the passengers, something like business or economy. Also, it contains information about the customer type, purpose of the flight of the passenger, satisfaction level of the on the in-flight Wi-Fi service, and other features. So what we will try to do now is from this data is to try to predict the passenger satisfaction based on the other features. The first thing that we will need to do here is to train the machine learning model. How we can do that is by simple inserting inside the MindsDB predictors table. How we can do that is just using the simple insert query that we will provide some information in. So what we're trying to do now is just do some insert query inside the MindsDB predictors table. And as parameters, we are adding the name of the machine learning model that we will build. So I will call that passenger satisfaction model. Let me just add a demo at the end. What we will try to predict is the target variable that we will try to get the predicted. So from this data, we will try to predict the passenger satisfaction. And the third argument here is the select query, in which we are telling MindsDB from where the data should be ingested. So we are just adding the select statement, and we are trying to select the values from the table. And just for the demo purpose, I have like a limit here, just because the data set is quite big and it contains more than 100,000 rows. So if I run this, you can notice that MindsDB started in the background. It's trying to do a black box analysis and start a process of extracting, analyzing the data, transforming the data. And it will take some time to train the machine learning model based on usually that depends on the size of the data, the columns types, and etc. How we can check that the training has successfully finished is we can do a select from MindsDB predictors table. So if we try to select, we'll get two records here. The one is passenger satisfaction demo model that we are trying to train now at the moment. And for the sake of demo presentation, I have one pre-trained, so we don't need to wait of this one to finish, as you can see here. So it says the status is completed, and for the previous one, it's still training. So while the model is still training, what we will try to do next is we can try to get the passenger satisfaction out of the trained model. Well, how we can do that? It's quite simple. We're running a select statement on the model, which behaves like it is a standard database SQL table. Let's select the predicted value and confidence, and the additional information in the select that we will add will be, let's imagine a customer that is loyal customer, that he rated that the in-flight Wi-Fi service in the are quite good, that he's traveling, the type of travel that he's doing is a business travel, and the class that airplane class that he's using is an economy. So if we run this select statement, you can see that MinesDB already returned the results back. So MinesDB thinks that the predicted value is that this customer is quite satisfied with the airline agency that he is using, and the confidence for this, MinesDB thinks that this value is like around 95% confidence for that. There are additional informations that we can query from the models, and that provide us additional statistics about why this prediction and why this type of confidence. So I will run additional select statement. So in this one, I have included additional satisfaction explain column, in which MinesDB will try to provide additional information. So not just the predicted value and confidence, but additional statistics. So let me just try that one. So it's quite similar. So we're just selecting the predicted value, the confidence, and the informations, and we are adding in the where clause the other features for getting these predictions. So here in the info, you can check that the predicted value is satisfied. So MinesDB thinks that this user was quite satisfied with the airplane agency that he's using. The confidence again, but there are additional information like the prediction quality. So MinesDB thinks that this is it's very confident for having this prediction. Important missing information. So what model thinks there are quite important features to have while training the model, but also when you're querying the model. So MinesDB thinks that the flight distance, the online boarding, and baggage handling are quite important for getting better prediction. And also you can see the ID here, which could be easily excluded. When you are creating the insert statement, you just add the remove parameters value, and you're including the columns that you want to remove from the training. Additional to that, we have an extra insights where we're trying to guess how MinesDB would predict if some of the values that we provided in the where clause are missing. So for example, if customer type was missing, the model would predict satisfied, and also it's returning the informations for the other features, and MinesDB is trying to guess those predictions. So yeah, it's quite simple what we tried to did here. So we covered two things. The first one, with a simple insert query inside MinesDB predictors table, we were trying to do the auto machine learning in the database and try and create the machine learning model. And the second one was using the select statement. We were able to query the model and get the predictions back from it. What I show you right now was through the PostgreSQL database. But here in the right side of my screen, if you can see, I have MySQL opened, and I can do the same thing from MySQL. So even if this one created from the PostgreSQL, you can connect to your MySQL and also do the same querying, the same training as it is in any other database. So just for this presentation, I will try to select everything from MinesDB predictors. And you can see here that we have the two machine learning models, the one that I have pre-trained previously and the one that we did through this demo. So you can see that the status is complete and we have around 94 accuracy. Yeah, so as an overall, it's quite easy. Anyone that have a general knowledge of databases and SQL can train and do the machine learning right from the database with just simple insert and select query. and it's not related just to one database. You can do that in the Postgres, you can do that in the MySQL. We have other integration like MariaDB, MySQL, ClickHouse, and other databases. On top of this, there is some graphical user interface that we have built for visualizing of most of the things that I already showed you. So I will just try and quickly share that one with you. So we've built this graphical user interface that we call Scout, just for explainability features, and everything that you can do through the SQL can be done here with few clicks around. So in the integrations tab, you can see that I'm already connected to the PostgreSQL and MySQL. The interesting part that I want to show you is data sources. So if you go to the quality tab here, what we will present right now is you can get the additional data analysis information, like score for each of columns, input values, and variability of those values in the data set. MindDB looks in every column, tries to analyze the data, figures out the quality, and shows suggestions and warnings about the data that you have. So you can see here, I have some warning for some of the features. So for example, for the customer type, we have a one warning that there could be a potential bias in our data. And MindDB is giving you a suggestion that you need to check the occurrences of variable on the data set. Also, if we scroll around, I guess there should be more. So if we check the arrival delay in minutes column, we can see that MindDB thinks there are two warnings for this one. So there are some potential outliers in our data. We can visualize those, and you can see from which values MindDB thinks that these outliers came from. Additional thing here is the predictors, where everything that we train through PostgreSQL can be done with a few clicks. And also you can do the same querying that we did with the select statement, but you can do it from here through our graphical user interface. So let me just try and show you that. So what you can do, you will select the model. You will just provide some information that from which you want to get the prediction. I will just add one for the demo purpose. And if you try and run the query, now MindDB will display the predicted value here. So you can see that for this query, MindDB thinks that the user was quite satisfied with the airline agency, and MindDB thinks that is 94% confidence for doing that. Yeah, I think that pretty much covering what we will try to present. And if someone has any questions, please share them on the Slack channel. And I think that Jorge will share with you our social profile so you can check what we've presented right now.
Hi, Zoran. Is Jorge talking anymore? Because we do have two questions that have come through. Who's shining those out, Jorge or yourself, Zoran?
We can take the questions right now and in between Zoran and myself, but let me share in the meantime this, and yeah, let's go for the questions.
Okay, all right. First one is, can I train the model with other data sources and query them from the database with SQL queries?
Yes, you can certainly plug in data sources from the following options that we have right now, which are like from files, URLs, information that lives in either ClickHouse, MariaDB, Postgres, MongoDB, MySQL, Microsoft SQL Server. And then you can just train from data that lives in any one of those, and then you can consume them from any of those databases as well. So right now, the ones that we can publish to are the ones that support the foreign data wrapper or kind of like a federated storage. And we also are adding other data sources such as Snowflake and like the usual data lakes, so that you can pull information from those, but still consume them from your normal database rather than your data lake.
Okay, thank you. And the second one is, can I tune parameters of the model, or can I use other machine learning libraries like Scikit-Learn, PyTorch, etc.?
Yeah, so you can bring your own models, so long they're either on Scikit-Learn or PyTorch. Those are the two frameworks that we support. And yeah, you can wrap your models around, and there's a way for you to like upload them through the graphical user interface.
Okay, thank you very much. I don't think we've got any more questions that have come in, unless Bronwyn tells me differently. So I think that's it from us. I think, Bronwyn, we've got another 5-minute gap now between now and the next presentation.
Yeah, we have. So just while we wait and begin our speaking slot on time, I am just going to play a short video here that will just fill the space a little bit, and then we will hand over to the next speaker.
Thank you.
Thank you, Jorge. Thank you, Zara.
Thank you, everyone.